My name is Bjoern Schelter. I'm from the University of Aberdeen. I'm presenting today our new Masters in Data Science and how we set it up. The presentation is together with Professor Marco Thiel.
Today, I'm going to talk a bit about our Master in Data Science, which we recently started in Aberdeen, and what we discussed, what we considered when we set this degree up. And this talk is by myself, Bjoern Schelter, and a colleague, Marco Thiel, who is in the audience as well. So if you have questions, feel free to ask either of the two of us. I know I need to finish on time because there's the next most important thing in this conference, or one of the most important things, the coffee breaks. So I'll make sure that I finish on time. That's the abstract. I think I won't read it out loud and just continue with our ideas. So what we wanted that Master in Data Science to be is a real hands-on one-year degree. So they really should touch data, they should work with actual data, not simulated data, industry data, research data, and learn how to process it. So from how do I collect the data all the way to how do I present the results. We intentionally wanted to accept a wide range of backgrounds and interests. So people from all areas. There wasn't, you didn't need a bachelor in mathematics or physics or something. Any background is fine because data science is relevant in all areas, so we invited them all in. And that also meant that a lot of these students didn't have prior programming skills. So that's one of the challenges we had to face, and that's obviously one of the reasons why we chose the Wolfram language rather than Python, R, MATLAB, and whatever else is out there, C, C++. I'll come back to this point repeatedly, so that's one of the key things. Yeah, that's the next point also. The entire degree is taught in the Wolfram language. We obviously show them that there's a Python interface, that there's an R interface, and so on, but the focus is really on the Wolfram language because that allows us to teach this degree in a highly interactive way. So it's not like you would prepare the normal slides. We do that, obviously. So if there are no questions, we can follow the standard way of teaching. But if there are lots of questions, and it turns out to be that's really what's happening, they keep asking. We almost start with a blank notebook, and they keep asking questions, and then we know what we need to teach in all the individual modules, but that allows us to respond and show them really this is how we would do it. It has another advantage that they see that we make mistakes because we had that discussed that at this conference repeatedly as well. You have this Polish presentation. They all look fantastic. They're all nice. They work. Everything works straight away. And if you do that to students, they look and say, "Oh, that's magic." Because when they try it, they make mistakes. Something doesn't work. And then they say, "Nobody told us what to do now." And if you start programming it yourself, you get it wrong, you make mistakes, they have an immediate, okay, if that happens to them, it's okay if it happens to us, and also they can see how we go about these mistakes and how we would try to fix them. So it's really, it needs to be more like a spoken language. If you learn a language, you wouldn't normally say, okay, Latin might be an exception, teach me the grammar, teach me the words, I go home, I translate this text, and tomorrow I'll give you my best possible translation. If you learn English, or if you learn French, Spanish, you wouldn't do it this way. You would just start speaking. You would start doing it in order to learn it. And that was one of the big ideas underlying this degree. So we really tried to teach the teachers and the students in this interactive way so that they really have this hands-on live experience. I tried to click, it worked. One of the key things, obviously, is when you set up such a degree, there are competitors out there. So before we could even start, the university would ask us, is there a market for that? And how big is that market? And so we went with their help and checked for various institutions what their programs are called and how many students there are. And you see they are like the University of Edinburgh. They have quite a big number of students, but there are also lots of degrees which are similar to a Master's in Data Science with fewer students over the years. And I can even scroll through that quite quickly because this graphical representation is probably nicer than reading all these numbers. So these discs basically show you how many students there are on these degrees. And just for those who don't know, Aberdeen is around there. I hope you can see that, yes. So we are in the northeast corner of the United Kingdom, even northeast of Scotland, as one of the bigger cities still there. And so the question is, are we competitive? What can we do? What degree do we need in order to attract a large number of students for a data science degree? If you look at a bit more detail and ask, and you don't need to be able to read the X label, but that's sort of the distribution of universities and how many students in data science related degrees they can cater for. And you see, left is University of London, so they have the capacity to cater for roughly, what is that number, 240 students or so, and then it drops quite rapidly. Edinburgh is quite up here. By the way, London might be represented a couple of times because there's University College of London, there's University of London, and so on, but this is basically the numbers in data science related degrees. If you then check, and that's taken, I just click here and hope it works. These are rankings for Great Britain, and you see the university name, and it's ranked by various criteria, student satisfaction, and so on. And the question is, has that an influence on the student numbers? And if you look at this plot, you clearly see that there is this link between the rank and the student numbers. You can even fit, and the word linear is a bit misleading there because we changed it ultimately to a nonlinear model. You can even fit a nonlinear model to this data, and you basically say 60 students is sort of capacity, and then it drops. And if you go for the ranking of the University of Aberdeen in the UK, which is 29, maybe I shouldn't advertise that so much, but still for a small city, it's quite good. You see that we can cater for tops something like, or we can expect from the ranking we have 40 students. So ranking is an important factor in all that. If you look a bit further, what's the degree titles and how they cluster? That's a cluster plot, and you see degrees in statistics in the upper left corner, for instance, which have a smallish number of students, 15 to 20, and if, I don't know where I need to click, but if I go over some of those, machine learning 60, these are then the outlier sort of, the programs that have huge numbers. Yeah. It's just the clustering of, yeah. Yeah. And the last question we had is, how do we name the degree? So we looked at, does the name matter? Do we need to call it data analysis, data analytics, data science? And you see most of the curves are quite flat. The data analytics one, I think that is growing a bit. So data science seemed to be, data analytics seemed to be a sensible title. The first thing then we did, we put the degree as part of our program on the web pages, students applied, and the students came in. And we use web forms to interact with the students, get their feedback, but we also used it to get to know them. So if I click here, you have these interactive, maybe I can make that bigger. Yes. You have these interactive questionnaires where you can ask certain things. So what's your highest degree qualification? What are you interested in? And so on. And if I go back here, yeah.
Why did you ask about cost?
Cost?
Yeah, zero. Clear out. Did you do it? I'm sorry if I missed it. How much does it cost to go to get a degree?
It depends. So that's where the Scotland is, or the university has pretty clear rules how much they would charge. So for local students, the fee is different from international students. And local students can, even if I'm not mistaken, can get scholarships from, or get it for free basically, and it needs to be then, or paid for by the Scottish government in our case. International students are more expensive, but that's sort of fixed. There's no wiggle room for us to change that. So that's basically what they determine. So if we then go and ask about these things, so how is your math skill, how is your programming skill, we get the following results for our students. So programming skills, as expected with that variety of backgrounds, is rated by the students themselves very low. So again, emphasizing we need an intuitive programming language. We can't tell them program that in C++ or C#, because they will in finite amounts of time struggle to get to a result. And the Wolfram language obviously allows the flexibility so that they can get immediate success, that they can get results quickly. We asked them, what is your interest? So what do you basically want to do? What do you want to do afterwards? What do you want to learn here? And what's encouraging, I think, is the terms data analysis, machine learning, big data, but also data management show up as the highest ranking interests. And that's obviously very important to become a data scientist, to have the ability to deal with all this. But you again see movies, languages, music, economy, politics. So they are really then, in their special areas, interested in various different fields of application. Again, showing the diversity, but also showing you need a language which you can cater for all of those quite easily. Which backgrounds did they have? Most of them came from engineering, geosciences, and economics. And then there's the other areas you can see there. And we also asked, do you have any comments? What do you want, basically, any other comments? And you see a lot of these feedback that we got, and that's a sample of that, understanding the topic of data science, understanding how to use data and data analysis. So they really came, as expected, to learn data science. Last thing, where did our students come from? And this map shows that we have a quite nice coverage of the world. Obviously, could always be better, but they come from all over the world. In parallel, we started to do also research into computational thinking. So we start with the teaching, but at the same time, we start the research projects. So what is the new teaching strategies? How do they work? Is computational thinking for that working? How successful are we? How well works the Wolfram language, the new initiatives into sort of mathematical data science learning? How well does that all work? And that's basically the letter that says we are allowed to do that, and it's part of a bigger picture, because we started that not only on the university level, but we started that going out to nurseries all the way up to university level and influencing the science STEM curriculum, if you want to put this way. This is how the degree looks like. Why study data science? I think it's pretty obvious, and there's lots of reasons. It's a field of high demand at the moment. You can do the computational access for all access, as Stephen Wolfram said on day one, so there's a lot of interest there. The syllabus of our degree you basically see in these different modules, and we have a total of 7 more like teaching modules, but this teaching really means interactive. It's not that we present a notebook and they can't ask questions. It's really they ask the question. We almost start, as I said, with a blank notebook. And the topics covered is Introduction to Programming, which is Introduction to the Wolfram language. It's similar to Gen 101, but in this interactive way. Then we have Introduction to Data Science. What does that mean? That really goes through the whole process, showing them how to get from data to something that is an output that I can interpret, and how do I interpret that, and what does that mean, and how do the next steps look like. Then there is a module on machine learning, then statistics and time series analysis, data visualization. Then we have the more advanced statistics concepts in module number 6. Audio, image, and video analysis is 7. And then there is this, which is a bit special, I think, case studies where we really bring in research from our university, but also guest lectures who show really worked examples. Yeah. The company X came to me with that question, I got that data, and that's how I did it. By the way, the concept of guest lectures is also very important, so we try to invite people from industry, we invite colleagues to present so that they hear firsthand what industry, what stakeholders, and what colleagues are working on and interested in. And then the last thing is they have to do their project over the summer, couple of months, and then that's what completes the degree.
If you handle semesters or how that handles, what set of these pieces are going in at the same time? Because obviously
No,
you just
no.
do a year or
Yeah, agreed. So we need to do that all in a year. And we decided, because they build on each other, so the introduction to the Wolfram language is the first thing, and without that, how do you use the Wolfram language in the next step? So we decided to do this as block-taught modules. Each of them are 3 weeks long, and then 2 of them are more or less with interactive teaching, and then the third one is the real hands-on tutorials doing it. But these tutorials and hands-on sessions are in parallel in the first 2 as well, but the third is really dedicated to allow them to work on these things themselves. Obviously, and that's questions we heard here a couple of times at this conference as well, why the Wolfram language? And that was a question that was also asked by the students. So why do we not learn Python or R? Because if you look at job adverts, they typically say knowledge in Python or R. So why Wolfram language? And this first graph shows the code efficiency, so how quickly can you get to something, and there obviously Mathematica is much more powerful than all the others. But on top of that, the immediate access, the direct access to this powerful code base so that you can get to results quickly. They asked us, can we make that even more tutorial driven, even more practical? So it's really now more a discussion, like in a language, rather than showing them. Obviously, we need to show them some of the commands and say, that's the functions, that's what they do. But then it is typically embedded in a discussion so that they really see why it's useful and where do they come from, rather than showing them, learn this function, learn this function, learn this function, and we show you at some point what to do with it. They asked for even more practicals, and they asked for guest lectures from experts or from industry that show that it's really relevant. And we incorporate that into the degree as I speak. The technology used, all lectures are recorded. The setup is ready for off-site delivery, so in principle we can broadcast it. But at the moment it's in the room, but everything is recorded. We even have short how-to videos for specific questions that are repeatedly asked, an FAQ in a video mode, so that they can come back and say, we have not understood the import function and what options I have, so there's a short video dedicated to that. The tools used are ranging from Zoom, CodeShare, all the way to Pushbullet to interact with the students and the students with us. Datasets, just briefly, other than the ones that are available in the Wolfram language directly, we use data from the Kaggle, from Amazon Cloud, Mongo Atlas, Statistica, EOS Land Viewer, to really work on real data sets out there so that they get the hands-on experience. This is how actual data looks like. As I already said, we hope, and you will see that in half an hour, I think. Is that correct? There is this computational conversation session where you really see that you can use the Wolfram language to discuss a topic based on actual code, based on actual data, and not based on some claims that people make. So that will be in half an hour. We do live coding at Hans gladiator fights, which is basically who can solve a problem more efficiently, faster, whatnot, and that person then goes to the next level and so on. We address current events, the small how-to videos I really already mentioned, Skype office hours, and all the lectures are recorded and potentially transcribed. And in the last 30 seconds, I just wanted to give a brief example how this works. And these are obviously not advanced examples. Oh, I have 5 minutes, good. These are not advanced examples, but just shows you what we do in order to engage them, in order to keep their interest. So the first one is, if I click on that, a sort of game where they learn about random events and random numbers. It basically asks them, can you try to send us a random sequence? Make up numbers and send them to us, and we will check if they are really random. And as we all know, humans are not very good at this. So if I download that, that's one example. One way of looking at that is, for instance, to calculate the entropy of these random numbers. And the number we get here is roughly 2.16. I think you need to remember that because of the font size. But if we then compare that to actual distributions of random numbers, so really we generate the random numbers, hands-on, let's do it, estimate the smooth kernel distribution of these numbers, plot them, and you see this number here is 2.22, this number is 2.32, the ones they produced is 2.15, that's probably somewhere here. So if you ask in the last line, what is the actual probability that this number is from this distribution of entropies? And the answer is 0. So that's not a random sequence. And they learn this now firsthand. They can program it, they can play with it, they can generate these results and see immediately the feedback, how a computer can, for instance, decide, did you produce random numbers or not? The egg hunt, I should click on that, is the idea you hide clues on web pages, you let them solve a problem, and then they will get to the next web page, which again has solve a problem, that gets you to the next page, and so on. Obviously, I can't do that now in the remaining. Now it's really true, 3 minutes to run through that in real time. But this is, for instance, one of the questions. Welcome to the next level. Download the data from this cloud object, and this list of numbers can give you a QR code if you represent it in the right way. And if you click on that, obviously, it's not really helpful. It has a sequence of zeros and ones, and if you just scroll through it, it obviously doesn't contain much information. So going back to Mathematica, they need various skills to solve this task. So the first is read the data in. Yeah, how do I import the data from the web? They obviously have seen that. They need to realize that when you do that, it comes in as a string, so you want that as an expression to get the zeros and ones back. And then you get this list, and then one way of doing it is, for instance, just look at the manipulate of that. And if I shift that here to the right and find the right M, then they get a new barcode, and this barcode gets them to the next web page. And if they solve that, then they should get to, that's the same command again. Oh, next step is gone. Ah, there it is. Don't know what happened there, but it didn't do it, did it? It did. It did. So you go to the next. If you click on that barcode, you see it points you to Dropbox and asks you to open these 2 images. And when I open these images, then it's a quite famous picture. And the question is, what do we do now? They have 2 of them. You might say, yes, let's go to the other one. And that doesn't open. We had that problem yesterday, and I don't know why. But what you would have seen is that. So they get pretty much the same picture. There's visibly no difference between the 2. And even if you go naively and say, let's take these 2 and calculate their difference, the answer is, there's not much in it. But if you then know a bit more about Mathematica and, for instance, the image adjust command, you see that there is a barcode hidden in tiny little differences in the black color that basically say what you should do to get to the next web page. And if you scan that with your phone, you will see it gets you to the web page that in this case says, welcome to the end of this egg hunt, you won the golden egg. And with that, and 16 seconds left, and the coffee break starting soon, I stop here. Thank you for your attention, and happy to answer questions.